Hi class, we're going to be taking a look at inverse functions in this video. In your textbook, it's lesson 4.2. So here's an equation, and maybe you recognize this. This is an equation that relates the Celsius temperature to the Fahrenheit temperature. The way that it's written right here, your independent variable would be the Fahrenheit temperature. And that's what your input would be. So if you knew what the Fahrenheit temperature is, you could put it in here for F, subtract 32, multiply by 5/9, and you'll get your output, which is what that would equate to in degrees Celsius. So if you know your Fahrenheit temperature, this equation is very helpful for finding Celsius. But let's say that you wanted to find the Fahrenheit temperature if you knew what it was in Celsius. So for example, you're in Europe and you hear that it is 20 degrees Celsius outside. What do you wear? What is that temperature in Fahrenheit? Well, what we could do is we could take and solve this equation for Fahrenheit instead of having it be solved for Celsius, meaning that Celsius is over there by itself. That makes it the dependent variable. It depends on what we input into F to get your output Celsius. So let's rearrange this. Let's solve this equation for F instead of for C. So I start with 5/9 times F minus 32. So to solve this for F, we want to undo the operations. So F, we're taking F, we're subtracting 32, and then we take that result and multiply by 5/9. Well, to solve it, we do everything in reverse order in the reverse operation. So instead of multiplying by 5/9, we divide by 5/9. Well, when you divide by 5/9, it's the same thing as multiplying by the reciprocal. So it'd be 9/5. And if I multiply this side by 9/5, notice the 5/9 and 9/5. Anytime you multiply a number by its reciprocal, it cancels out. And so we have 9/5 C equals F minus 32. And then instead of subtracting 32, we would add 32. So we have 9/5 times C plus 32 is equal to the Fahrenheit temperature. So now if you take this equation, if you know the degrees Celsius, you input it here. So now your Celsius is the input and the Fahrenheit's the output. So these are inverses of each other. And that's what our topic is going to be today. You guys have worked with inverse operations pretty extensively. In order to solve any equation, you need to know the inverse, how to work with inverse operations. We want to undo what is happening to x in order to solve for x. So the inverse of multiplication is division. And I want you guys to fill out this chart all the way to square root. So what is the inverse operation? All right, so the inverse operation of division is multiplication. The inverse of squaring is to take the square root, addition, subtraction, subtraction, addition, and square root and squaring. So your inverse operations undo the original operation. So an inverse operation, like let's say that you multiply by 3. So I take this x and I multiply it by 3. Well, then the inverse of that is dividing by 3. If I multiply by 3 and then divide by 3, it cancels out and it's like you've done nothing, essentially. So kind of similar with inverse functions. Functions that undo each other are inverse functions. So anything that's happening to x in the original function, the inverse will do everything in exactly the opposite order and the exact opposite operation. So if you look at this x right here, this function f of x equals x plus 6 divided by 2. You're first taking x and you add 6 and then you divide that result by 2. Well, if you look at the one below it, here's my x, I'm multiplying by 2 and then subtracting 6. So instead of adding 6 dividing by 2, I'm multiplying by 2 and then subtracting 6. I'm doing the opposite operations in the opposite order. And what happens when you have an inverse function is whatever your input value is, you'll get an output. So for example, if you put in 4 into the original here, 4 plus 6 is 10. 10 divided by 2 is 5. The one below here, g of x, is the inverse of f of x. And if you find g of 5, I take that and I multiply by 5, and then I subtract 6, which is 10 minus 6. I get the input from up here becomes my output for the inverse. Okay, so let's look at how, first we're going to look at some notation for inverse, and then we'll look at how to find the inverse of a function. Okay, so if you have a function f of x, the notation for inverse is this right here. It looks like a -1 exponent, but what it means is it's, the way you would say that is f inverse of x. And it indicates the inverse function of the original. If it's not called, if the original function is called g of x, then the inverse notation would be g inverse of x. Okay, so when I have a, if I ask you, I'll say f of x equals, I don't know, x cubed minus 8. And then I might say find f inverse of x. You'll need to know what that notation is asking you to do. It's asking you to find the inverse relation, because not all inverses are going to be functions, which we'll look at in the second video. Okay, so with an inverse, and it's with the function and its inverse, this is what you need to know. All x and y ordered pairs get interchanged. So, because our inputs and our outputs switch. So let's say you have a point on a function f of x. Like let's say we have the point 3, 9. Well, if 3, 9 is on the original function, then the point that I know is going to be on the inverse function or relation is going to be 9, 3. The x's and the y's, the inputs and the outputs, are interchanged. So if you had a point like -12, 7, what would the corresponding point on the function's inverse be? It would be 7, -12. So you just interchange x and y, which leads me to how to find the inverse of a function. There are 2 steps. So you got to know just the 2 steps. Step 1, and you should write this down in your notes, interchange x and y. And step 2, solve for y. So, and again, remember this notation. So let's do a problem or 2. So we have our original function here. Sometimes it'll say f of x instead of y. If it does, it can be helpful to replace f of x with y, because our step 1 is to interchange x and y. So I'm going to do that. Interchange x and y. Step 2, we're going to solve for y. So interchanging x and y, I'm going to have x equals 1/2 y minus 1/2. Step 2, solve for y. All right, so if I'm going to solve for y, first step is I have x equals 1/2 y minus 1/2. So we're going to, y is getting multiplied by 1/2, and then we subtract a half. Well, what we're going to do is the opposite. We're going to add 1/2. Add 1/2, so we get x plus 1/2 equals 1/2 y. And then we're going to divide by 1/2, which is the same thing as multiplying by 2. So if I multiply by 2, I got to multiply this side by 2, and I have to put that in parentheses. So I get 2 times x plus 1/2. This 1/2 and the 2 cancel out, equals y. And this is my inverse. And in this case, it is an inverse function of the original 1/2 x minus 1/2. I can also distribute this if I want to. It would be 2x plus half of 2, which is 1. So that is f. That is the inverse function. Number 2, I'd like you guys to stop the video, try to find the inverse of for number 2, y equals 3x, and come back and check. So in the first step, I interchanged x and y, and then in step 2, I divided by 3, and I got x divided by 3, or that's the same thing as 1/3 x equals y. So that would be the inverse function of y equals 3x.